Okay, so here's question number 4 from section 9.1. Okay, so chapter 9 is all about hypothesis test. So here we go. 11% of all Americans suffer from sleep apnea. A researcher suspects that a higher, it's very important, higher percentage of those who live in the inner city have sleep apnea. Of the 340 people from the inner city surveyed, 54 of them suffered from sleep apnea. What can be concluded at the level of significance of alpha 0.05? Okay, this is a hypothesis test, which means we're testing a claim. So the first thing you do, here I've got the steps. This is the exam 3 notes. So the exam 3 notes that I passed out in class. Actually, this part is chapter 8, number 1 and 2, right here, number 1 and number 2. This is chapter 8, and then if you turn the page over, this is, again, the exam 3 notes, number 3 and number 4, which notice is all about hypothesis tests. And then here's the last part from the exam 3 notes. So let's look at the exam 3 notes. Specifically, here's where hypothesis tests start on number 3 on the exam 3 notes. It says, first off, that you need to write the claim. That's going to be P equals a number, greater than a number, or less than a number. Let's go back to it. So there we go. So let's write the claim. All right. So to do that, you got to realize what's being claimed. So what is being claimed? What's being stated or wondered? A researcher suspects. That's going to be, what does he suspect? That a higher percentage have sleep that who live in the inner city have sleep apnea. Higher than what? Higher than 11%. Right? Because 11% of all Americans suffer from sleep apnea, and the researcher suspects that a higher percentage of those who live in the inner city have sleep apnea. So the claim, so here's how we're going to write it. P higher, what's higher? Greater than 0.11. So that's, right, see how I'm following this right here? This right here? P equal, greater, or less. I did greater. P greater than a number. Next, you're supposed to write the HO, which is P equals a number. So next comes the HO, called the null hypothesis. Null is a fancy word for zero. That's the zero hypothesis. Null, it's a fancy science word for zero. So the null hypothesis is going to be the same letter and the same number, and the H1 is also the same number and the same letter, both P.11, P.11, same as the claim, but they're going to have different, like equals or greater or less or not equals in between. How do you know what it is? Well, the HO is always equal. See that back here? The HO is always equal. Now, how do you know what the H1 is? The H1 is going to have to match the claim. One of these two, either this one or this one, has to be identical to the claim. Here's the claim, greater than 0.11. So therefore, the H1 has to be greater than 0.11 so that it matches the claim. This is the same as the claim. That's always the case. Either HO or H1 will exactly match the claim. All right. So now, here's the other thing you do. You always write weak evidence, that stands for evidence, next to HO, and strong evidence next to H1. This is just like a court of law. HO is the assumption of innocence, and H1 is a strong evidence leading to guilt, right? In a criminal case, you assume that the person being tried is innocent. You assume HO. And if evidence is weak, if there's not a lot of evidence, if the evidence is weak, you're going to stay with HO and assume they really are innocent. Whereas if evidence is really strong, you're going to go with H1 and convict them of guilt. All right, that's exactly what a hypothesis test is like, HO and H1. All right, so here we go. For this study, we should use, and the answer here is P. We're using P on this one. And then the HO is P equal to 0.11, and the H1 is P greater than 0.11. The test statistics. So now we go to our TI 83 or 84 graphing calculator. And specifically, we're going to do the, if you hit stat and then go over to tests, and then go down, we're going to do the one prop Z test. One prop Z test, which is number 5. Go down to the one prop Z test, and when you do, it'll ask you P0, X, and N. So what are those? Well, the P0, that little 0 is supposed to make you think of the H0. So you're supposed to go right over there and just grab whatever number is next to the H0, 0.11. That's always what you do with the P sub 0. And then the X, what is the X? Well, the X will always be, well, let's do the N first. How about the N? The N is always the total number. What's the total number of people in this problem? 340 people, right? 340 people were surveyed. And so there's only one number left. The 54, that's got to be the X. That's the number who had sleep apnea. So there we go, put those numbers in there. And the last thing is the calculator will ask you if it's not equal, less, or greater. How do you know which one it is? It's always exactly what's in H1, which is greater. So you grab that one. Same direction. See how that one's that way? This one's this way. Exactly the same. Just grab that there. Hit enter, hit calculate, and let's get some numbers. So I'm doing it on my calculator right now. I'm getting, all right, so here's what I got. I got a Z value, so the test statistic is Z equals, your calculator will tell you, how many places it want here? It wants 3 decimal places. Z equals 2.877. And the P value, it tells me 4 decimal places. That was 3. 4 decimal 0.000020. All right. Now, here's what we have to do. Here's the most important part of the problem. So we have our p-value, 0.0020, and then you put right next to it, the alpha level, which is right here. That's called the significance level. The significance level, which is 0.05. 0.05. All right, now if it helps, add 2 zeros so that they both have the same number of digits, because we're going to compare them, and that'll make it easy to compare. So see what we're doing. You put the p-value down, and you put the significance level just to the right of it. Put it to the right. That'll make it easiest. Grab it from over here. And now ask yourself, which of those is bigger? Which of those is greater? Well, the significance level is greater. So the wide side of the symbol goes towards the one that's bigger, right? Remember how the greater than, less than symbol works, right? He has a wide side, and then he has a narrow side. The bigger number goes on the wide side, the smaller number goes on the narrow side of the symbol. So we're saying the significance level is bigger. All right, so what? Well, here's what that means. Here's the most important statement that we'll use again and again and again and again. If the P is low, the HO must go. That's the statement. You can see all this on the exam 3 notes down here. It tells you what to do on your calculator, one prop Z test. And here's the conclusion. If the P is low, then HO must go. If the P is not low, then keep HO. So the question is our P low? What do we mean by low? How low? Lower than what? Well, look right here. This p-value came out less than the other number. So less is low. This P is low because he came out less. Less is low. If it was the other way, if the symbol came out like that and the P was higher than the significance level, then we would say that P is not low, and then we would do the opposite. The HO would not go away. So that's how you make your conclusion. So in our case, the P is less. The P is less. The P value here is lower than the significance level. So the P is low. So if the P is low, the HO must go. What do we mean go? Go where? Go away. That's what we mean by go. That catchy little saying, if the P is low, the null must go. If the P is low, HO must go. Go away. HO must go away. You can see, because the deal is we're trying to decide if we believe HO or we believe H1. They're like two attorneys arguing a case, and we're either going to agree with HO or we're going to agree with H1. And so this tells us right here, if the P is low, the HO must go away. So cross out the HO, it's going away, and circle, keep, believe H1. The statistical evidence backs H1, not HO. We crossed out HO because the P was low, HO must go away. Crossed it out, and we kept H1. So let's go write that stuff in. Here it says the P value is less than, right? It was less than the alpha. And based on this, we should, now what should we do? The null must go away. How we say the null goes away is we say reject the null. That's how we say go away. We reject it. Reject the null. If the P is low, the null must go away. We reject the null. All right, now we're ready to make a final conclusion on G. They want an answer from us. So let's come on down here. See if we can do this. So what are we going to say? Let's go through it. Now remember, we circled H1, which is this, which means evidence was strong, right? We crossed out HO, and we circled H1, which says strong evidence that, let me clean this up the way it was in the beginning, P is greater than 0.11. There's strong evidence that the claim is true and that the percentage is greater than 0.11. Remember the inner city people? The researchers suspects that higher than 11% who live in the inner city have sleep apnea. Well, he's right. At least the evidence, the statistical evidence, supports his claim strongly. There's strong evidence that the percentage who have sleep apnea in the inner city is greater than 0.11, which he was claiming. That's where the statistical evidence goes. Let's read these words. The data suggests that the population proportion is not significantly larger than 11%? No. It is larger than 11%. That's wrong. The data suggests that the population proportion is significantly larger than 11% at alpha 0.05. So there is sufficient evidence. Yes, there was strong. Strong means sufficient, right? Sufficient means enough. There was strong evidence. There was sufficient evidence. Yeah, that looks good. That's right. The other one was wrong here. We can see that the other ones were wrong. The data suggests population is not significant. No, that's wrong. Yes, that's it. So here's our answer. We got that one. This is the correct answer. Now let's go on to H and I. So here's H. Now I'm just going to give you a quick little rule for always doing H and I, because they're really not worth our time. We don't really need to worry about H and I. They're going to be the same every time. Here we go. It's going to be always the one that says if the population proportion. So H is always the one that says if the population proportion. That's always the one for H. I'm not going to test you on this. I don't care about this. I couldn't remove it from the homework, so I'm just giving you the shortcut. For the H on problems number 4, 5, and 6, here in, this is 9.1, problems 4, 5, and 6, when they have H, it's always going to be the one that says if the population proportion. Not going to give any more meaning than that. And then for the I, come down here and we'll do the I. For the I part, for the I, well, I'll just circle the I there. For the I, it's always going to be the one, it's one of these population proportions again. And it's the one that says if the population proportion is, oh, sorry, not that one. That one says is larger, so he's not the one. We don't want that. If population proportion is a number, that's the one you want. So for the I, it's always the one that says if the population proportion is a number, not larger, but is a number. That's the one it's always going to be for 4, 5, and 6, part I. So we got H and I. Only problems 4, 5, and 6 have H and I. 1, 2, and 3 don't have that, so you don't have to worry about it. So I'm just giving you the answer in advance. For 4, 5, and 6, H and I, it's always going to be done just like that. Okay, so here is question number 6. Let's try this one. So you're conducting a study to see if the proportion of voters who prefer the Democratic candidate is significantly different from 50% at a level of significance alpha 0.05. According to your sample, 43 out of 80 potential voters prefer the Democratic candidate. All right, so the first step on every hypothesis test problem is to write the claim. And what are they claiming, or what are they testing or trying to figure out? To see if the proportion of voters who prefer the Democratic candidate is significantly different from 50%. So if the proportion is different from 0.50. So how do you say that? What's the math symbol for different? It's either going to be equals or not equals or greater than or less than. Which of those means different? Not equals, right? If something is different, then it's not equal, right? Because if it's equal, it's the same, right? If two things are equal, they're the same. So if they're not the same, they're different, they're not equal. So that's what we put. Whenever they say different, we put not equal to 0.50. That's what they're claiming. That's what they're testing, to see if the proportion is not equal to 0.50, if it's different than 0.50. All right, that's a claim. And now from there we write the HO and the H1. Now remember, HO and H1 always have the same letter and the same number as the claim. Just all three are always the same. P and 0.50, P and 0.50, P and 0.50. The HO always has equal in the middle, every time, no exception. And then the H1, one of the two of them, either HO or H1, has to be identical to the claim. Since HO is equals, always equals, it can't be the same as the claim, so then H1 is identical to the claim. Right, claim right there by H1 because it's identical to, right, see how this claim is identical to H1. Now we always write weak evidence next to HO and strong evidence next to H1. Because H1 always has the strong evidence, HO always has the weak evidence. All right, so we're studying P. It's a proportion, it's a percentage problem. HO is P equals 0.50. HO is always equal. And H1 is P not equal to 0.50. They're always opposites of each other, right? HO and H1 are like two attorneys arguing for a case. They're opposites, and we're deciding who we're going to believe in a hypothesis test. We're deciding which one has statistical evidence backing it. All right, so now we go to the calculator, and we go to the 1 prop Z test, which we get under stat, and then tests. If you go to stat and then tests, and then you go to the 1 prop z test, and then it'll ask you for the p sub 0, the x, and the n. All right. So how do we know what those are? The p sub 0, that little 0, is supposed to remind us of the h sub 0. Whatever number h sub 0 has, which is 0.50. So we put that into p0. The x and the n, you know the n is always the total number. What's the total number on this one? It looks like 43 out of 80. So it's 43 out of 80 total on that one. Put that into the calculator. Oh, and then you gotta, and then the not equals is the last thing. You put whatever's in H1, you put that in there. Not equals, and you hit calculate, and let's see what we get. Okay, so I'm getting a z value equal to, once what, 3 decimals? So I'm getting 0.6708, so 671. And then a p value equal to, once 4 decimal places, 0.5023. Okay, so now we've got to try to decide about the p-value. So what you do is, you remember, you write down the p-value, which is 0.5023, and you write right next to it, just right to the right of it, the significance level, because that's what we're comparing. What is the significance level? Right there, significant level of significance, 0.05. It's usually 0.05, but not always. All right, and then we've got to decide which of those is bigger. It might help to fill in 2 zeros back there so that they both have the same number of decimal points, so it's easy to compare. So which one's bigger? 5023 is bigger than 0500, isn't it? So the wide side goes towards the bigger one. So in this case, the p-value is bigger, isn't it? The p-value is the bigger one. So this means the p is not low, is it? Our p-value is bigger than the significance level. The p is on the wide side. The p is the bigger one. The p is not low. So remember the statement, how it goes. If the p is low, so in our case, if the p is not low, the HO does not go away, right? So, because the saying is, if the p is low, the null must go. If the p is low, the HO must go. So if the p is not low, the HO must not go away, because our p is not low. He's greater than the significance level. So the HO is not going to go away. What does that mean? The HO is not going to go away. That means we're going to, the way we say it in statistics language, is we're going to fail to reject the HO. We're not going to reject the HO. The HO is not going to go away. So I'm going to keep the HO, and I'm going to cross out the other guy, right? Because the P is not low, the HO does not go away. I keep the HO, I circle the HO, and I cross out the other guy. I fail to reject the HO. I don't reject the HO, I fail to reject the HO. So what does that mean I believe? I believe everything the HO says, which is P equal to 0.50, and the evidence is weak. All right, so let's go down and try to, so let me put that in here. The p-value is greater, right here, greater than alpha. Comes from right there. And based on this, we should fail to reject the null hypothesis. And now for our final conclusion. Come in here and take a look at it. Is it the first one? The data suggests the population proportion is not significantly different from 50%. Is that true? Is it not different from 50%? Yeah, that's true. Right here, it's equal. Right? We're saying it's equal. Right? We rejected the other one, and we're keeping HO, which says it's equal to 0.50, which means it's not different. It's equal to 0.50. So that's good. Let's read on and see if the rest of it is good. So there is sufficient evidence. Is there? Oh, no. There's weak. There's weak. We crossed out the strong evidence, H1. We're keeping weak. Weak means not sufficient evidence, right? There's weak evidence. There's not sufficient. There's not strong evidence. There's weak evidence, not sufficient, not enough evidence. Evidence is weak. So no, that one's not right because it says sufficient evidence. Let's try the next one. The data suggests the population proportion is not different from 50%. Right, that's true. Not different from 0.50 because it's equal to 0.50. That's what the evidence led us to. That part's true. So there is not sufficient. Right. Perfect. That's our answer. That's the one we want. See how we determine that? It's all coming from whether we accepted HO or H1. We picked HO, right? Because the P was not low. The HO did not go away. We kept HO, which told us the evidence was weak, and P equals 0.50. The third one was wrong right here because it says the data suggests the population is different from 0.50. No, that's not right. It's equal to 0.50. It's not different from 0.50. It's equal to 0.50. So there we go. Let's go do H and I. H and I are the same every time. We'll go to a fresh screen on those. H, remember I just told you every time, H will be the one that says if the population proportion. Every time. Just grab that one. Don't worry about it. It's not going to be in the test. I will always be the one that also says population proportion, but there's two of those. So how do you know which one? Is a number. Not is different, but is 50%. There we go. So we don't want that. There it is. That's the one for that. This is the one for that. Every time, that's all you got to do for those.